Okay, guys, so this second part, we're going to be looking at the idea of spread, and we're going to talk about three specific types of spread. The first one that we're going to look at is the idea of range. If you're following along in your book, we're kind of right about page 59 in your book is kind of when we talk about the range, and it's measuring the distribution between the min and the max. What is that value? How far away is the max away from the min? So there's another type of measure of variability or measure of spread, and it's called the standard deviation. And the standard deviation is measuring the typical distance of a value from the mean, or like you might hear me say, it's like measures the average distance of value is away from the mean. Okay. Now there's a complicated formula that we could do, and you guys sort of did this when you did MAD, or mean absolute deviation. You guys did that a lot in middle school. And even in Algebra 1, you guys talked about standard deviation, and you may or may not have used this complicated formula. But we're like finding the standard deviation of the sum of all the differences of each score is away from the mean squared, and we divide it by n minus 1. Okay, that's just the formula to calculate it. I'll talk more about it when I see you guys in person, okay? All right, so let's look at a set of data. It's the same one that we've been looking at. So we're looking at 2, 4, 5, 6, 7, 8, 8, 9, 15, 16. And it's already in order, which is nice. And we're going to try to put this into your calculator. So what we're going to do is we're going to press stat. Then we're going to press enter on edit. And we're going to do 2, 4, 5, 6, 7, 8, 8, 9, 15, 16. Alright, I guess I had those in already. I didn't have to do that. But what we're going to do next is we can press second and mode to clean out of that. We're going to press stat, and then we're going to move the arrow to the right to go on top of one variable statistics, and then we're going to go down to calculate. Hopefully you guys are following along and doing this at the same time I am. Okay? And we're going to press enter. Now, there's lots of different values. We talked about x bar being your mean. Do not worry about these two for right now. We're going to talk about that standard deviation of x. Okay? S of x, whenever you see S of x symbolically, S of x is always going to be your standard deviation, or your sample standard deviation. Okay? And in this case, your sample standard deviation, S of x, was 4.47. Okay, that was what your standard deviation is. And if I were to do this formula by hand, I would get that specific value. So how would I interpret that? Well, I would say that the average distance each Instagram like is away from the mean of 8 likes is about 4.47 likes. Okay? So that's standard deviation. Now, when I look at standard deviation, there are some properties that go along with it. S of x, or the standard deviation, will always be greater than or equal to 0. I could have a standard deviation of 0. If that is the case, then there is no distance away from each score away from the mean. So that means that all the scores are the mean. That's what that's telling us. The larger that standard deviation is, that means that the more spread out my data is. Standard deviation is not a resistant measure of variability. And S of x variations about the mean. So one of the things that we'll notice, guys, is that S of x will be synonymous with the mean. Those are related to each other. Because if you remember for mean, the mean is not a resistant measure of center, just like the standard deviation is not a resistant measure of variability. Okay? And just the basic interpretation when we look at that is it's the average distance each score is away from the mean. That's kind of what we're looking for in regards to interpreting what the standard deviation is. There is one more measure of variability that we'll look at, and that is called quartiles. So if I look at data, like we talked about how the median is the 50th quarter, okay, that's the middle. Well, I can also split data into two other quarters, and I can call that the 25th percentile, and also talk about it as being the 75th percentile. The 25th percentile is called the first quartile. It's like the middle of the left half of the data. And the third quartile is the middle of the right half of data. Okay? So what I'm going to do also then is look at the idea of how do I come up with the interquartile range, and that's a measure of variability. The interquartile range is calculated by taking the third quartile and subtracting the first quartile from it. When I look at the interquartile range, it's measuring the middle 50% of the data. Okay? Alright, so let's go back to this data. Okay? The same values that I was looking at before. Now, what I'm going to do is I'm going to go back to my calculator. And I have this data. So if I want to recalculate the data, I'm going to go back. I'm going to go press enter on one var stats. And then I'm going to go all the way down to calculate. And what I'm going to do is I'm going to move my arrow down. So that's my min. That's going to be important if I wanted to know what my range is. I could use that. I also have the first quartile, which is 5. I have a median at 7.5. I have the third quartile at 9. And then the max is at 16. So these are going to be important things because I can use this 9 and 5, that Q3 and Q1. Remember, Q3 minus Q1 is my IQR. So if I take 9 minus 5, that's going to get me an interquartile range of 4. So when I look at my data, my IQR is going to be 4 likes. So that means that the middle 50% of likes are 4 likes. So I can use interquartile range to help find outliers. And these are going to be two important formulas. And if you guys look in your notes, it says something that's important to write down. These are two things that it's going to be important to know. Anything that's a low outlier is going to be whatever value is smaller than Q1 minus 1.5 times IQR. And any values that are bigger than Q3 plus 1.5 times the IQR is going to be an outlier. So let's just look at an example. This is the same data that we were looking at before. So to calculate any outliers, I'm going to take Q3 plus 1.5 times my IQR. So I'm taking 9 plus 1.5 times 4. So I got 9 plus 6, which is 15. So any upper outlier needs to be bigger than 15. Well, do we have any values that meet that case? Yeah, we do. 16 would be considered to be an outlier. 15's not, because 15 is not bigger than 15. Let's look at the low end. I'm going to take Q1 minus 1.5 times the IQR. So I'm going to take 4. I'm going to subtract 1.5 times 4. So I got 4 minus 6, which is 2. Negative 2. That's a difference, right? So anything lower than negative 2 is an outlier. Well, we have none in that case. So 16 would be my outlier. Okay? So let's kind of put this all together and try to find all of these. We're going to look at this set of data. Okay? So what I'm going to do is I'm going to put these data points in my calculator. Okay? So I'm going to press stat. I'm going to press enter on edit. Now, one of the ways that I can clear my table is I will never press the delete button. Never press that. But I can go all the way to the top, press clear and enter. Clear and enter gets rid of all my data. So I'm going to type in each of those numbers. I got 86, 84, 91, 75, 78, 80, 74, 45, 87, 76, 96, 82, 90, 98. I have to go up here. I see it right there. I know you guys are yelling, Mr. Graham, you made a mistake. So I'm going to do 47, 45, 87, 76, 96, 82, 90, 98, 83, and 47. So I have these pieces of data. I'm going to press stat, and I'm going to go to calculate, and I'm going to press enter, enter, and I get these values. I got 79.5 to be my mean. I got my median to be 82.5. I got my standard deviation to be 14.84. And, alright, so I'm going to write those down here. Okay. So looking at this, alright, I got 79.5 is my mean. So the average grade was 79.5. All right, I got the median to be 82.5. All right, the 50th percentile grade was 82.5. My standard deviation I got was 14.84. So the average distance each grade was away from the mean was 14.84. So there is some variability going on there. The IQR, we're going to take Q3 minus Q1. So I got that to be 88.5, I think. Let me just double check. Let's look at our table. Yep. Let's see. 88.5 minus 75.5. And you guys get that to be 13. Your range is going to be 98 minus 45, which is 53. So one last thing that we got to kind of do is try to figure out if there's any outliers. That's the last part. So we're taking Q3 plus 1.5 times the IQR. So we're taking 88.5 plus 1.5 times 13. And I got 108 when I do that. So there's none in that case. Well, if I do the other end, Q1 minus 1.5 times IQR. So I got 75.5 minus 1.5 times 13. And I got that to be 56. So let's go back here. Let's look back at these other values. Is there any values that are smaller than 56? 47 and 45. So those would be your outliers. 47 and 45. Okay. I'm going to ask you guys to look at question 8 for me, and I will show you guys the answer in the next video.